Hey guys, Jared from Parker Mountain Machine here, doing a video today talking about the FN SCAR Mark 17 as well as the Mark 20. We get a lot of questions here at PMM regarding gas jets and what gas jet to run in my SCAR 17 or the Mark 20, for example. As you can see, we've got a bunch of suppressors laid out here in front of us, and I'm going to go over some specifics dealing with this system and how it's affected by overpressure issues and other small nuances and variables that need to be considered when putting a suppressor on your FN SCAR Mark 17 or the Mark 20, as well as the Mark 16, for example, as well too. The Mark 16 isn't as affected by some of the system variables that the Mark 17 and the Mark 20 are going to see, but all this information is useful and it can carry over. Alright, so the most common question that we get here at PMM via phone call or email, sometimes even Instagram messages, is what gas jet to run in my SCAR, whether it's suppressed or unsuppressed. And that question is an incredibly loaded question because it's just not straightforward. There are a million different variables to consider. And I'm going to go over all these variables for the Mark 17 and the Mark 20 so you, the end user, can do your due diligence for your particular weapon system in your particular place to get the gun to meet the standards that you want. First and foremost, what I will say is any of the barrels that come out of PMM are always going to be slightly overgassed. You might be asking yourself, why would you overgas a gun? Pretty simple answer to that is an overgas gun is always going to run. And that is to taking into considerations dealing with how dirty the gun gets, or altitude changes, barometric pressure changes, temperature changes, humidity. These are all factors that I'll go into a little bit more in detail on. But a slightly overgas gun will always run. So first and foremost, this is my PMM gas jet sheet that I keep downstairs on my workbench for when we're doing barrel work for these systems downstairs. I will publish on the website what the factory configured variants of these weapon systems come with for gas jets. But just to throw it out here right now, if we're dealing with a SCAR 16, the 16-inch barrel usually sees a 1.35 or a 1.4 millimeter gas jet from the factory. The 14-inch is a 1.45, and then the 10-inch SCAR 16 CQC comes with a 2.0 millimeter, 2 millimeter gas jet. One caveat to consider with the factory barrels is inside the actual gas system where the selector valve is, there's a deeper cut relief in an effort to aid an overpressure issue with a suppressor in the suppressed setting. The 16-inch barrels don't have that, so in an effort to mitigate that and saving money on sending the barrels into us, we can balance the system out a little bit better by putting a different gas jet in it. So factory gas jets on the Mark 20, 1.4 millimeter is what I've measured here. We're using gauge pins. So we've got Vermont gauge pin set here that we drop in the factory holes, and that's how we measure them. The 16-inch SCAR 17 uses a 1.45 millimeter for a 16-inch barrel right out of the box. And then the 13-inch CQC, 1.6 millimeter is what we've seen here. So those are your factory numbers when it comes to dealing with the Mark 17 and the Mark 20 and different barrel configurations. 16 to 13 are the factory barrels, 20-inch on the Mark 20. We haven't formally cut or commercially made available the Mark 20 CSR barrel, which is a 16-inch variant of this, but we might do that here shortly. Okay, so earlier I was talking about variables, and I'm going to go through variables one at a time and how those variables can affect the overall performance of your system. First and foremost, when the Mark 17 was designed by FN for SOCOM, this gun was spec'd for an M80 ball ammo. And the suppressor that they ended up going with was a derivative of an AAC can that was signed off by the FN engineers. One thing to consider in the process of manufacturing this system to accept that suppressor is the ammo and the can were tested highly by FN to make sure that that particular combination, through a varying degrees of variables, like I talked about earlier, barometric pressure, altitude, temperature, was not going to create an overpressure issue in the system. Everybody who has one of these guns knows that the bolt carrier group is exceptionally heavy and large, and it carries a lot of mass. The main issue with any of these systems is if you put a suppressor on the end of the barrel, we're creating an overpressure issue no matter which way you look at it. And physics dictates that that energy being captured in the suppressor has to go somewhere else. Some of it can be bled off in the gas system here in the selector valve, in the suppressed or non-suppressed setting. Suppressed setting obviously for a suppressor. But a majority of that energy is going to be transferred rearward into the bolt carrier assembly as part of the reciprocating mass. And if you have a can that has a notorious overpressure issue, all that energy cycling forward and aft in the weapon system gets transferred via harmonics into the surrounding components. Everybody who owns a SCAR, first question is, what optic do I put on my SCAR? I've heard SCARs are really hard on electronics. Yes, they're hard on electronics because they have a really big heavy bolt carrier. Downside of the system perhaps could be that they're hard on optics and they're hard on things around them, but also what makes the SCAR so unique in its system is that heavy bolt carrier as a 308 platform is hand down the softest shooting 308 in the world right now. So it's a balancing act. You want a soft shooting 308 where you can shoot multiple rounds on target fast and accurately. Physics dictates that you have to suck up some of that energy somewhere again. So that's where the bolt carrier comes into play. Okay, so now that we've touched on the bolt carrier group a little bit and the harmonics involved in the system and how it's affected by overpressure issues from the can, let's talk about some of these suppressors that we have here in front of me. So moving right to left, we've got two variations of a Surefire SOCOM 2 cans. I believe one is a 7.62 mini and the other one's just a 7.62. We've got a Silencer Co. Saker here. This is a Surefire 300 SPS. Dead air right here. This is a Sig Sauer. It's a SRD 762 QD. We've got the Gemtech 1 can here. This is the Sandman K, and this is the Sandman Standard. And then the Omega, which is a can that a lot of guys like to run on this. So, talking about the variables with suppressors, two things to consider with a can that's going to determine an overspeed issue with the bolt, which is a byproduct of back pressure. Internal volume in the can is your first consideration, and baffle design. It's no secret that a suppressor is meant to suppress, right? Everybody thinks a suppressor is designed to make the gun quiet. So when talking about suppressors, we here at PMM look at it from a little different standpoint. A lot of people, the first thing they say is, how quiet is the can going to be? Suppressors were originally designed to be used in a theater of combat by warfighters. And their primary goal is to maximize, or I should say, minimize shot signature by maximizing the operator's potential to engage targets and not give away their position. That means hiding flash and hiding sound. But to a certain extent, the quieter a can is, generally speaking, it's going to induce more back pressure on the system. It's a lot like a muffler on a car. Anybody who's ever messed around with cars, maybe when they were younger, you go out and you get your new Volkswagen, Audi, Honda, a lot of Hondas, Toyotas, Subarus nowadays. The first thing that they're going to do is an exhaust upgrade. That exhaust on the car just went from being quiet and comfortable vehicle to drive to now a loud car. And that's a byproduct of less back pressure on the system. For a car, it creates less back pressure, meaning that the air can enter the engine and exit the engine faster, thus giving you more horsepower. With a suppressor, generally speaking, the quieter the can is, means that the internal volume as well as the baffle design is creating a little bit more of a back pressure issue because it's capturing more of that gas and that energy inside the can, therefore making it quieter. But as I touched on earlier, making the weapon system quieter adds a physics equation, meaning that that energy has to go somewhere else. Ammunition variables. Anybody who's shot long enough on a rifle or a pistol knows that certain ammo comes out at different velocities. Different velocities means that that projectile has different kinetic energy behind it. How does that affect this system? It affects it because a hotter burning load out of that projectile generally is going to create more back pressure in the suppressor. And the only way to mitigate that is in the gas system and trying to bleed off some of that energy. So that's one thing that you've got to consider. The other consideration with ammo is heat, as well as altitude variances too. So I don't know if you've ever done this, but next time you go out to the range, if you take 5 rounds of whatever ammo that you're shooting, and you take those 5 rounds and you put it in the shade, and then you take another handful of 5 rounds and you put it out in the hot sun and leave that ammo in the sun for about 30 minutes or so, and then you get behind your gun, say you're at 100 yards, get on that gun, fire those 5 rounds in the cold, take a look at the variable between your point of aim and your point of impact on the cold rounds, and then immediately take those hot rounds. Generally what you're going to see with the hot rounds is a point of impact shift because the ammunition sitting in the sun is warmer and it has more kinetic energy when it fires. So it's a hotter burn. So you're going to see a point of impact shift. Now that point of impact shift is going to vary depending upon your zero. It's also going to vary depending upon the distance in which you're shooting at the target. As the bullet is still climbing, as it's starting to fall, has the bullet stabilized depending upon what the projectile is that you're using. So that's first thing to consider is on an ammunition side. Next variable to take a look at here is geographic location. Where do you live in relation to where I live? So we're here in New Hampshire. I'm in Stratford. We're approximately 50 feet above sea level, I think, if my memory suits me correctly, which is great. Barometric pressure at sea level is 14.5 bar. Why we use bar is beyond my comprehension still, but 14.5 bar. So that's standard air pressure. If you're living in Colorado, in Greeley or Denver or something, you're at a higher altitude. Higher altitude means thinner air. There's less oxygen up there. So that's going to be something that you have to consider too when trying to set up your weapon system to operate where you want it to operate. Going back to what I was talking about with an overgassed gun, you can set a gun up that's slightly overgassed at sea level. Generally speaking, at higher altitudes, the gun should still run because the air is thinner, less comprehensive burn, there's less oxygen. Recently, here in New Hampshire, the world record was set for the Mount Washington Hill climb in an electric car. Is this a surprise to me from somebody who comes from racing? Absolutely not. And the reason being is electric cars don't have to contend with variables in oxygen for your lean mixture. Most of the standard internal combustion engines that people are out there driving, running up hills, one of the things that they're constantly fighting with is the fuel mixture. We've got modern electronics that can kind of correct for that for a little bit, but if you're driving a race car, a highly tuned race car, much like what you want to do with your SCAR here, you want to tune it to be the most effective. Something that might work really, really well at sea level for that race car is not going to translate while you're at the top of Mount Washington. Electric car doesn't have to worry about that because there's no gas being burned. Another thing that's really interesting too is if anybody out there has any information on World War II history, the Germans with the old BF-109s, they actually had nitrous in those planes that they would use at higher altitudes because it was a cooler blast of air that would help them run better. And then anybody who might have a grandfather that flew in World War II in the Corsairs in the States or the Hellcats or any of the planes, those pilots were constantly messing with trim, which is you've got to change how lean or how rich that airplane is running depending upon altitude. Now, obviously, a rifle and a weapon system is not going to be as subjective to those two examples in the car that I just presented or an aircraft flying, but it does make a difference based on where the gun's being used. So that's another variable that needs to be considered and accounted for on your end. Okay, so the FN SCAR 17 and the Mark 20 and the dreaded canted receiver issue. This comes up all the time on the internet when dealing with these weapon systems. If, for some reason, your gun is starting to see canted bolts here in the rear, that is most likely a byproduct of a couple hardware changes that you've implemented outside of the factory. Now, I've heard people say that they've seen SCARs come from the factory with canted bolts. I have in my possession here, we've got a Mark 20, there's two Mark 17s, 5 Mark 16s. None of these guns have canted bolts from the factory. FN's built their name on being the world's most battle-proven or battle-tested rifle, and they stand behind that. Not throwing anybody under the bus here, but one of the things that we all need to be accountable for with these weapon systems and anything in life is what you change to the gun can ultimately affect the way that the gun runs over a long period of time. It's just like buying a brand new car. I've used this analogy before. If you go down to the Porsche dealership and you're fortunate enough to buy a brand new 911 GT3, and then you decide that you want to go put aftermarket wheels and tires on it that weren't originally engineered for that car, you make them larger, you're creating more friction on the drivetrain, and you blow the differential or the transmission in the car. That's not Porsche's fault. Porsche never originally designed it for that. If you do a flash to your ECU and the motor blows up, that's not Porsche's fault. A lot of that has to carry over to this too, guys. And someone who comes from the racing world, I understand the repercussions of tinkering with things. And I accept full responsibility for it. We here at PMM, we try and go out of our way to answer as many of these questions for everybody, but the hard reality is you have to be accountable for your weapon system in the way that it functions. So bear in mind what you have on the gun. So getting back to the canted issue. Number one, do you have a suppressor on the gun that's creating an overpressure issue? Some cans that have been tested, we've seen up to a 32% overpressure issue, which means that the bolt carrier in the gun is now moving rearward 30% faster than it was ever initially intended to. And going back to the mass of that bolt carrier, on the Mark 17 with a 16-inch barrel or a 13-inch barrel, it's engaging a small primary buffer, which is a piece of rubber, and then it engages what's known as the hinge system for the folding stock, but that hinge system is actually a secondary buffer system. On the Mark 20, anybody who's fortunate enough to own one of these guns too, if you take a look at the adapter where this stock bolts to it, this is acetal. It's actually a polymer. This is not a piece of metal. There are aftermarket stocks out there that people sell, and I'm not trying to throw anybody under the bus here, but the hard reality is you are changing out a critical component on this weapon system that was designed to soak up the energy from the bolt carrier into the rear of the stock. Plastic flexes, metal usually does not. Another analogy that we use here at PMM that I use all the time when talking to my SCAR guys on the phone, hypothetically, let's think that we're in a vacuum right now, and I was holding a golf ball at exactly 4 feet off of the ground, and I took a 1/4 inch piece of plastic and I dropped that golf ball, and we were able to use a laser and we could measure the rebound height. So we get an exact value of the rebound height on that plastic. We then replicate that test with holding the golf ball exactly 4 feet, and we drop it on a 1/4 inch piece of aluminum. Physics dictates that that aluminum is going to redirect the energy up because it's just harder by nature. It does not soak up the energy as well. And that's one of the factors that people need to be mindful of. Changing the gas jet in the system can only mitigate that so much. Same thing applies with the suppressors. This is, for all intents and purposes, putting a band-aid over a bullet wound. If you have a suppressor that is creating a massive overpressure issue and possibly have an aftermarket accessory on the gun that is not sucking up that energy moving rearward. And basically what we've got in these systems is we have a heavy ass bolt that is bouncing back and forth in a violent game of death. And all this energy is being dissipated outward towards the upper receiver or the rear hinge assembly and the rear bolts. So something's got to fail. Or the electronics, right? This SCAR here has killed 2 LA5s for me. What am I going to do about that? Not a whole lot, right? Naval Special Warfare uses a NAVC version from L3 for these guns, which is quote-unquote a hardened version manufactured by L3. I don't know what that means because I've never actually seen one in person, but I suspect it probably just has a lot more epoxy, or not epoxy, but silicone around the electronic components inside it that acts as a buffer to soak up some of the harmonics from the weapon system as the bolt carrier engages towards the rear of the receiver, and then it comes back home going into battery. So something to consider with that. Generally speaking, if you look at any of the PMM SCAR 17 or Mark 20 variants that you see here at the shop, they're all going to run the factory stock. And the reason that we run the factory stock is it's plastic, it soaks up the energy. Like I said, the Mark 20 does have an aluminum PRS style adjustable stock on it, but pay close attention to the interface between the rear hinge and the stock. It is plastic. Its job is to suck up that initial impulse from the bolt carrier striking it. So it sucks that energy up and can more easily dissipate that energy to the surrounding components. If Mike Tyson was standing in front of me and he had a 6-inch pillow strapped to his hand, I'd much rather take a punch in the face with from Mike Tyson with a 6-inch pillow strapped to his hand than just bare knuckle or a piece of steel or aluminum. That energy is just going to get translated. So that's another thing to consider with the SCAR. So going back to our golf ball analogy, with the reciprocating mass and components of this system, I gave you a breakdown of just holding the golf ball static in a vacuum at 4 feet. What if we were to put that golf ball in a slingshot and then launch it at that plate? What do you think the rebound height would be difference in that scenario? That's what a suppressor is doing to the bolt carrier in these guns. It's adding more back pressure to drive that backwards. That's why these have a valve on them to bleed off some of that energy. All right, now you've got a bunch of information. You can listen to me ramble. How does this apply, and what's the best way for you to make an educated guess as to what system is going to run best for your gun and your application? So we make a variety of gas jets here at PMM. Generally speaking, I don't recommend anybody run anything less than a 1.3. I personally don't even like the 1.3 because in my experience, it puts the gun tuned to the ragged edge of its functioning capabilities. Meaning that as the weapon system gets dirtier, as variables that we talked about earlier change, the gun might not cycle. Case in point, we've got the PMM Hell Monster here. This is a 12-inch SCAR. This gun runs phenomenally well up here in New Hampshire in the winter, with a 1.3 gas jet. I once took a trip down to North Carolina for the very first SCAR group gathering and neglected to pay attention to what gas jet was in this, and a friend of mine and myself were going to do a hog hunt that night, and we were confirming zero, and I went to shoot the gun down there in North Carolina, and she wouldn't cycle with a 1.3. It was under gas, just the way it was going. I had this gun set up in the middle of February here up in New Hampshire, where it's colder than a witch's tit, and the air is real dense, so it doesn't need as much oxygen to do what it needs to do to function. We get down to North Carolina, it's 90 degrees, the humidity level's through the roof, it's hot as all hell. It needed a little bit more oxygen and more energy to get the system to run. What gas jets to use in your system? Standard protocol here at PMM goes like this. When a customer calls us, this is what we recommend. And this is what I do. If any of you guys out there have a barrel from me that I've cut, I will put a gas jet into the barrel based on the length of the barrel that we've cut it, that will theoretically work. And it's slightly overgassed, excuse me. There are alternates included with your barrel. Generally speaking, there is a gas jet that is a millimeter smaller and a millimeter larger. And the reason for it is this. When it comes to testing this system, there are two tests you have to conduct in order to get the gun to be functioning under what you deem acceptable operating standards for you. And I say you because the way that you want this gun to run is way different than the way that I want it to run. I've had some guys complain, oh, the gun recoils way harder now. Well, I don't pay a whole lot of attention to that stuff. I want a gun that's reliable, that's going to run. If it's got a little bit more of a recoil impulse on the Mark 17, a teeny bit more, even on its worst day, either of these two weapon systems is going to beat a G3, an M1A, an FAL, any other 308 system out there. These things are incredibly soft shooting for what they are. So, how do we test these guns? First test that you're going to do, you're going to take one round, put it into the chamber. Make sure the gun's in battery, gun's on safe. Take a 20 round loaded magazine and stuff it into the mag well. What we're doing here is we're creating an artificial scenario, meaning the top round on the magazine, the fully loaded magazine, is engaging under maximum spring tension along the bottom of the bolt carrier of this gun while it's in battery. Get on the gun, get your sight picture, break that shot. The SCAR 17 as well as the Mark 20, when it ejects, the brass should come out and it should engage the brass deflector and travel at a 45-degree angle rearward of the ejection port. That's where it's going. So, with that test, you want it to eject. It goes off the deflector at an angle out towards the rear. If you're saying 45-degree angle, what does that mean? Just take a look at the actual brass deflector on either of these two weapon systems, looking down from the 12 o'clock position. That's the angle that the projectile should generally be going. Obviously, as it engages that, it's going to deflect a little bit, but that's where it should be going. So what does this test tell me? Under an artificial condition where the magazine is under full spring tension up against the bolt carrier, we have fired a round, and what we're looking for is the gun to, number one, eject the spent brass, but more importantly, does it have enough energy for the bolt carrier to travel far enough back to grab that next round off the top of the stack of the mag and send it back into battery? Does it do that? Pretty simple with a SCAR to check that. You can look at your charging handle and it'll tell you exactly where the gun is in relation to being in the battery. If it does that, boom, thumbs up. We're good to go. That means we passed test one. Test number 2, the bolt lock back test. Pretty simple. It is exactly what it just sounds like. You're going to take one round and you're going to put it into the chamber of your host system. With an empty magazine in the gun, I want you to fire and make sure that the bolt locks back. If it locks back, cool. We've passed test 1 and we've passed test 2. We have a functioning gun. Could it be overgassed? Absolutely. Will it run in a variety of conditions? Absolutely. Is it ideal for you? I don't know. You make that decision. Here's how we can do it. Once you've passed the bolt lock test, you can buy an array of gas jets off the website, and you're going to step down the gas jet size in the gas system by 1 millimeter. And what we're looking for is for the gun to fail the bolt lock back test. And what that means is that it does not have enough energy during the dwell time after the shot is broken for it to drive the reciprocating assembly of the weapon system far enough back to get the magazine to lock. Get the gun to lock back on the last round. So you can test it to its failure point. Generally what I say to guys is, hypothetically, let's say that the gun has failed on a 1.2 millimeter gas jet. Okay, the bolt's not locking back. Step it up a 0.5 millimeter. It should lock back now. But that is a weapon system that is on the ragged edge of being tuned to run. Meaning that it's running right now on the ragged edge for your location, your ammo, but it may not run as those things change. So 1 millimeter over where it fails the bolt lock is fine. You can even go up 1.5 millimeters. Generally speaking, if you haven't changed any other aftermarket accessories on the gun when it comes to the aftermarket stocks, and of course the suppressors there's a huge consideration to be made here with your can. 1 millimeter over bolt lock back should be fine. And that's all, of course, relying on you cleaning your guns. I don't clean anything here at Parker Mountain Machine. This SCAR 16 up here on the wall is creeping on upwards of 80,000 rounds. I think I've had Travis clean it twice in its lifespan. So she's on her 3rd barrel. This gun here is up around 35-ish thousand rounds. So 2nd barrel, maybe it's been cleaned twice. We've traveled twice formally out of the state to the SCAR group gathering down in the Carolinas, and I think I had Travis clean them then. Other than that, cleaning for me is taking the lower off, and I just add more oil to most of my guns. I'm not recommending you do that. Most guys aren't going to do that. I can tell you personally, I've never put a bore snake through any of these guns. I just run them, I beat on them, they're test tools for me. So that's another thing to keep in mind. Okay, so I'm going to touch on a couple suppressors here, and by no means is my recommendation throwing anybody else's product under the bus, but the hard reality is there's certain suppressors that work exceptionally well with these systems and some that just don't. And when I say don't, that doesn't mean that the suppressor won't work on the gun for 100 rounds, maybe 1,000 rounds, but over a long enough firing cycle of the system, you get up and say like 10 or 15,000 rounds, all those variables we talked about earlier compound, and it just adds to a lot of the issues that I've been talking about here earlier. So generally speaking, suppressors that are good to go, any of the Surefire SOCOM or SOCOM 2 series, these cans were designed by Surefire for warfighters, going back to what I talked to before. Are they the quietest cans in the world? Absolutely not. They're not designed to be the quietest. They're designed to be rugged. They're called the SOCOM series of cans because they pass the SOCOM test protocol for a suppressor, meaning that they have a specific standard of fire that the suppressor has to go through, and it has to survive and not blow up, meaning that an operator could use it in the field and it's going to last. Also, the Gemtech HD line of cans. This is a Gemtech 1. It's a titanium can. It's made for multiple calibers. Works really, really well with the SCARs as well. One of the cans that is the worst on the SCAR is the Omega. It's an exceptionally quiet can. It's a fantastic product for a lot of other weapon systems out there because it's user configurable with the end cap and everything. But this can in particular does create a massive overpressure issue on these systems. We have the Dead Air Sandman and the Sandman Ks here. Generally speaking, these cans are also pretty good to go. I haven't done a ton of extensive testing on these ones. These are more so, the information that I've gotten is anecdotal, and it comes back from customer feedback in the field on them. But they're pretty good to go. The SIG cans, they've got an overpressure issue with them too, because these are very, very quiet cans for what they are. Can they be used? Absolutely. Any of these cans can be used, like I was talking about before, can be used on the system. But the thing that you have to consider in the end is how many rounds are you actually going to put through the gun with the suppressor and its lifespan. I suspect most folks that own a SCAR, because of the barrier to entry on the system, as well as what it costs to feed this gun, if you're going out to the range and you're putting 100 rounds down range through 308 at 40 cents a round, I'm a machinist who's terrible with math, but I think we're talking about 60 or 70 bucks maybe right there just in ammo, not including the consumables and everything else. So the hard reality is a lot of guys probably don't get a whole lot of time on these guns and higher round counts. Like I said, because of the nature of what we do here when we're designing products and stuff, these are test tools, so they get beat on heavily. This gun's actually been launched across the range, approximately 50 feet in the air and maybe 30 feet out. Landed. I broke the plastic hinge assembly on it. LCAN, everything else is good to go. I wouldn't recommend you do that with your SCAR. It's a very expensive thing for most people. But a testament to the gun, it was sitting in a mud puddle. I picked it up, racked it, shot it. The stock didn't work. Maybe I'll put that video up. It's pretty funny. So going back to the cans here. Certain cans that are really, really good and certain cans that aren't. When people ask us here at PMM what can to run on my SCAR, general rule of thumb for us is the Surefire SOCOM and the SOCOM 2 series of suppressors, good to go. The Gemtech HD line is good to go. The Dead Air cans are pretty good, some of the other options out there, like I said, awesome products for what they do, just not ideal for this particular setup. And it's not a slight on them, it's just the hard reality of the situation here. One thing to do touch on, with the SOCOM series, the 300 SPS, this is designed for a 300 blackout projectile that doesn't have the velocity that you're going to see out of a 308. So these are designed to be a little bit quieter because it is for a 300 blackout can, and it does have a little bit more back pressure. This can, you can tell, has been heated basically to the brink of its existence, and for a long period of time it's largely lived on the Hell Monster, and it works really, really well on that gun. That gun is kind of a unicorn because it's a 12-inch SCAR. I don't even recommend to any of my customers to go that short, and this can was never designed to be run on a 12-inch 308, so it was kind of me just messing around with some testing here to see what it would do to the weapon system. That gun in this can's got probably close to 7,000 rounds out of the Hell Monster on it, and then it's been on some other host systems too. So in summary, as I said, this is all information for you guys, the end users, to take into consideration. Apply what I've talked about here for your systems out in the field. If you're active on the forums or active on some of the Facebook groups out there, discuss it amongst yourselves. Use what I've applied here in this video. Hopefully it can help you guys out. And if there's information you don't like and you want to go on the boards and talk trash about me, by all means, have fun. I like it. It gives me a good laugh. But anyways, Jared from Parker Mountain Machine here, signing off on the Mark 17 and SCAR suppressors and gas jet variables.